So on Blackboard, there'll be an area, a link, a course area on the left that says class videos. And so later in the day today, I will put up the link to today's class video. And by no means is that a reason to not come to class. Quite on the contrary, okay? Coming to class is essential. The video is for you to go back, reflect, reinforce what you've learned, and review, okay? It is not a substitute for class. Okay, so let's talk about comparisons. Here's in 1975, natural science and engineering degrees for 124-year-olds, just an indicator of our interest in math and science and our success in it. And how's the United States doing? Towards the top, right? What about in the year 2000? What do you think in the year 2000? How are we doing? Okay, so something happened. Something's happening. We're falling behind when it comes to science and engineering. We're falling way behind some of these other countries. Okay, and that's just, this is one way to look at that as natural science and engineering degrees. Okay, any company that hires you now, we're in a global market, you know, in the information age, and so you're competing against people from all over the world. Okay, from all over the world. So any company that hires you will compete. You will compete with these other countries. Okay, so there was a research called the TIMSS video study, and they videotaped 100 randomly selected classrooms in Germany, Japan, and the US, and then they made transcripts that took all the cultural aspects out. And then they had other people read those transcripts, so they had no idea if that country was from, if that classroom was in Germany or Japan or the US. And they analyzed the data for what's called high, medium, and low quality instruction in the classroom. Okay, so first, Germany, they found that 28% of the time spent was high, 38% medium, 34% low. And in Japan did better. 39% high quality activities going on in class, 50% medium, 11% low. What do you suppose it was in the US? What do you suppose it was in the US? High, medium, and low. How about the percentage of high? 0. Okay. 89% is what they considered low type quality activities and instruction in the classroom. What do you suppose that's talking about? What kind of things in the math classroom would be considered low quality instruction?
Basically just going over examples, not really explaining them.
Okay, examples, right? So it's just mimicking teachers' examples. How many people have been in a math class where the teacher did examples and you were expected to mimic them? It's low. What else is low? Quality yeah. Okay, good. So you don't have any creativity to think. You're just forced, this is the way you're going to do it, my way or the highway. Good. Yeah. Memorizing. Just memorizing stuff. Okay? So that's basically a very rigid classroom of learning procedures, mimicking examples, and memorizing definitions and formulas. Yeah.
I was just thinking back on my last semester is I had a pre-calc class, and the teacher didn't know how to deal with a student such as myself. I haven't had math since 2001, and he didn't know what to do with that.
Okay.
So
all right.
The quality of it was just terrible.
Okay. And so then what do you suppose high? So what's going on in Germany and Japan that's not going on in the U.S.? Any ideas? Yeah.
They entertain questions from students about real world examples.
Okay. Okay. So real world context, a dialogue with students. What else? Yeah.
They focus more on the theory and then they make you apply it.
Okay. Yeah. So it's not just about memorizing procedure, but really understanding what's going on. Understanding what's going on. We have technology now, computers that can do procedures, solve equations, in an instant, right? Which feels like, it's super short time they can do. But still, lots of classrooms are working on to do it the long way, do it by hand when we've got computers that can do it for us. So Any other ideas? What is high about? Yes, sir.
In Germany and Japan, the educational system is a lot more competitive.
More competitive.
It's not,
They don't hold hands. The students have motivation to really, they want to do well. Okay, yeah, so these are all good things. So the point is that the way that you may have experienced the math classroom is not the only way, okay? It's not the end all. There's something going on in other countries that, according to this study, which they worked hard to make it an unbiased study, there's something going on that's a lot better outside of our country. So I want to just make you aware of that, okay? So what is calculus? Just a bunch of complicated procedures? Who's heard of Wolfram Alpha? Yeah. So it does hard things for you lightning fast. What is, so you just write in, what is the integral of sine x cosine x dx from 0 to pi over 2? And it gives you, a whole myriad of different ways to look at this situation as an expression, as a graph, as a formula, okay? And it does it like that. Okay, GC, we're going to talk about graphing calculator today. Here's a very difficult derivatives. This is a kind of a procedure. You put that in, and GC just gives you this kind of advanced expression very quickly that would take several minutes for you to solve by hand if you knew the procedure well. Okay, so in the past, you learned calculus because you wanted a job that required lots of computing, and they needed people that could do it flawlessly and super fast. Okay, so people using calculus were given functions equation. Their job was to do what they were told. But today, we have computers. We have Wolfram Alpha. We have graphing calculator. Can do these things far more accurately and faster than any human. Okay, but computers, can't decide, can't make the important decisions of what to analyze or what to solve. So that's where we come in. And so now, in terms of learning calculus, it's more like you're a manager rather than a human computer, because we got the computers to do it for us. Okay, so this is our goal. You need to understand what you're doing and be able to explain why you're doing it, instead of just mindlessly performing a task that someone else wants you to do. Okay, so reflecting honestly, when you worked with symbols and performed computations, to what extent did you understand what it all represented? Okay, so this class is about developing expert knowledge of calculus so you can figure things out, not just remember what you should do. So in the end, the tool is that you can problem solve. You have tools that you can apply and solve something new that you've never seen before. Okay, so if something I present as new seems familiar, like you've had calculus before, many of you have, pretend it isn't. Don't anticipate, oh, this is where he's going, because if I don't go there, then you've tuned out. So try learning it with understanding and meaning, and just pretend you don't know where I'm going. Okay, stay with me in the moment, and really go for the understanding and meaning of what we're doing. Okay, so what's the moral? Good in math instruction in the U.S. is not good by international standards. There's a whole other world out there doing things differently and succeeding beyond us, okay? And don't expect this class to reflect the experience you've had in a prior class. Okay, so we've talked about this. Rote memorization, replicating examples, getting answers, guessing what I want you to say. What this class is about, understanding. Developing insight to the world of quantities and relationships. Seeing ideas coming in groups. Okay, so we're not just going to move from one section to the next. It's all going to, the ideas are going to be interrelated. So things are going to build on each other. So everything you learn in the first week, you're going to need all semester. And then the second week, you're going to need all semester. So don't learn something just to do well on this quiz or do well on this test, because we're going to see it later, okay? And the fundamental theorem of calculus is kind of the endeavor of the whole course. So the whole course, we have this endeavor to understand the fundamental theorem of calculus. And so everything we do throughout the course will be aimed at understanding this one fundamental principle, okay? Fundamental theorem of calculus. Okay, so Tale of Two Students. There's this thing called Rate My Professors, in case you didn't know about it. I do. I know about it. Here's one of my reviews. He's honestly a terrible teacher. Nice person. But tries to teach the why and forgets about the how. It really kills your grade. I've never had below a 95 in a math class, and now I'm hoping to get an 88. Okay? So, here's what I suppose, and I would guess that I'm right. I could be wrong, but here's what I suppose. What is this, to this student, what most likely is a good teacher? We've talked about it. One who demonstrates and explains complicated procedures really well and then assigns grades based on the ability to mimic them. Does that feel, maybe that's accurate for what this person was expecting from a math class? And a good teacher. Okay, but this is the kind of instruction that's put U.S. far behind other countries in our math ability. Okay? No matter what scale you look at for judging U.S. against other countries in math, we are at best in the middle, and lots of times toward the bottom. And we believe this is a big part of it. Okay? Another student wrote me an email. For the first 4 weeks of class, I left every day feeling that my brain had been mauled into abstract obscurity. But now I was actually helping my friend from another college with her Calc 1 homework. She was amazing how much I knew. And even though our language was a little different, I was able to teach her why each piece works, what it's there for. I've also been helping people at my table from class. It is so satisfying to be having these daily aha moments finally. So, what's the moral of the story? If you work at it and you stay with it, you can make a journey from what you're used to something new and something better. Okay? Where you're actually understanding things, and that gives you, empowers you, okay, to solve problems, to help others, etc. So, this is what's going to happen. When tackling problems in the course, common reaction you'll have is, he never did one of these before. TA didn't show us one of these before. Okay? So we're here to give you the building blocks and tools, okay, so then you will rely on your understanding to solve rather than an example or procedure. Bringing together ideas. We learned this idea over here, we learned this idea over here. Could you bring those together and understand and make a new idea for yourself? Transfer your knowledge to new situations. Write coherent explanations of your thinking. Okay? You're only going to improve in your problem-solving skills if you are put in the place where you have to problem solve. It's only going to get better if you're regularly engaged in problem solving. And so that's uncomfortable, right? That's uncomfortable. But expect that, okay? So when you get help, expect guidance and questions both posed back to you to help you figure it out, okay? So we're not going to tell you the answer. We're not going to show you how to do it. We're going to draw it out of you. We're going to question you and help you figure it out for yourself. Okay, so that one guy said it really killed his grade, right? So he was expecting a 95 and he's getting an 88, it killed his grade. So in a past semester, here was the breakdown. It's the same as other calculus courses, okay? So, it's not that everyone gets a 1 grade lower in this class, okay? If you work hard, you can still achieve any grade that you want to get, okay? So this is very typical for all Calc 1 classes here. Okay, that's that. So just in summary, meaningful learning requires hard work. It takes patience, perseverance, and help. You need to get help, but the benefits are great. Okay, in 12 minutes. All right, so have I gotten your attention? It's going to be different. It's going to be uncomfortable, okay? But it's worth it. So make that journey from what you're used to in math classes to meaningful learning, okay? All right, so graphing calculator. So let's get out graphing calculator. If you open it up.
Sir,
Yes, sir.
do most of the calculus instructors here have the same outlook that you do, or if we have a different professor next semester, they're going to be doing things differently?
Yeah, so this course is part of a research project of developing it, and our next goal is to develop Calc 2, but we haven't done that yet. So that's a good question. I think I'll be teaching Calc 2 in the spring. Okay, so I would certainly continue in the same vein. But you're right. If you have a different instructor, it may feel more like what you've traditionally had in the past. So, but as our research group that's developed this course is working on developing Calc 2 also. Okay, so when you open up Graphing Calculator, you should see a window like this with a little pink box.
Sir,
Yes, please.
do we have an alternative graphing calculator if this title can't run those programs?
Yeah, I can talk to you. What kind of lap?
It's just a Surface tablet. With a
Yeah, we can work on it. Yeah.
I got it.
Okay. Or if you the thing to do if you have a calculator or a computer at home, to definitely get GC on your desktop at home, and then just kind of look on work with somebody else in class, something like that. Okay, so when you open up GC, it should be like this, and so this is called a command line. When you see that square there, that's command line. So you can just type 3 + 6. As soon as you have a valid expression, it will give you an answer to that expression. So let's see here. Settings, make it a little bigger. So you see I have 3 + 6 = 9. Now if I say plus 12, 21. So anytime you have a valid expression, even as you're building it, anytime you have something valid, it's telling you what that equals. Okay? So you can cut and paste, you can highlight. If I highlight this, and then hit parentheses, just all I have to do is hit left parentheses. After it's highlighted, it'll put parentheses around the whole thing. And then I can come here and times -4, and it just updates. It always continually updates the answer, okay, of what you've got. So you can build. So then you can highlight the whole thing, hit divide. It makes a fraction for you. And always currently giving you what this thing equals. Okay, square root on a Mac. You can do Option V. So if I highlight the whole thing and then hit Option V, it puts a square root over the whole thing. What is it for Windows? You can try Control R. Anyone? No? Control Shift R. Control Shift R. Does that do it? Control Shift R is root. So there's some different keyboard commands. We have a list of all the different commands for GC and for Windows, and that's posted on Blackboard. Notice here I've done the square root of a negative number, but it still gave me a complex number with an I there. If you've seen that before. So I don't want it to be. I want it to be a real number, so I'll take the negative out. So this 3.6808. Okay, so just as a little practice problem here, can you write one expression in Graphing Calculator that would calculate the area of the region outside the circle but inside the trapezoid? Our goal is to write it as in one command line, not to find this part and this part and this part and then put them all together. Can you write in one command line an expression that would calculate the area outside the circle but inside the trapezoid, given this? And I've given you the area of a trapezoid there, 1/2 base 1 plus base 2 times height, and the area of a circle is pi r squared. So, and only use the values in the diagram. So don't do any of your own calculations along the way. So only using 4, 5, and 9, build one expression to find that area. See if you can do it. So you can work together. You can get help from us. Yeah.
Can I say something about how they should also be using pencil and paper? Because a lot of them are like staring at their screen and not having a place to like play around with stuff. If you prefer not.
I can just say, I can just remind them sometimes that they should be taking notes along with it. So, yeah.
So you're going to build an expression to get that radius.
You don't have, so everyone's working on it, whether you have GC or not. You're working on it. You can write it out on paper. Okay? So 9 is half the base. It's also the distance to the tangent point. And then the distance to the tangent point to the vertex is 4. Does that make sense? Oh, something works. This is 4. Yeah. 9 is from here to here, and 9 is from there to there. So the height is not given. You have to figure that out. Yeah, for pi, just type pi. For pi, just pi, and it'll make the symbol pi. So what have I shown? What have I done right there? What did I just do? This is the idea of this exercise. Okay? To find what? Height of the trapezoid, right? It's going to be a leg of the triangle. So it's going to be hypotenuse squared minus a leg squared, square root. That gives me the height. So now I want to keep building upon that expression, right? Only 4, 5, and 9 in your expression to do this. Only 4, 5, and 9. So that's the idea behind this. So we can build around that expression to get the area that's being asked for. Okay, keep going. A couple minutes left.
That's the area of triangle and circle.
That's the diagram here. So that's solving for the leg. The height of the trapezoid.
Oh, okay.
We got 5, and 4 plus 9.
Okay, and then, so you were
That height first.
then that would be the same as that. But what about the area of the circle?
So now how are we going to get the area that's outside the circle inside the trapezoid? How are we going to get that? What's that? 1/2 base 1 plus base 2 times the height. So that is? What do we want? We want the area inside the trapezoid but outside the circle. So then what? We want to subtract off the area of the circle, right? Pi times. So now watch. You can copy and paste, just like in a word processor. What's that? That's our height. So copy. I paste that in here. And what does the height have to do with the radius? Half of it, right, is the radius. Half of the height is the radius. But we need to square that. I lost the answer though. Okay, so for Monday, if you go to Blackboard, okay, for Monday, if you go to Reading and Assignments in Blackboard, you'll see that you have your assignment for Monday, and that's to study Chapter 1 and complete the exercises, and you want to use GC as much as possible, getting those answers in one command line, just like I showed you there, okay? So on Blackboard is your assignment. If you want to stick around for a moment and get more clarification on this example, we will be here. Okay?